Hello everyone, welcome to my YouTube channel Chemistry Quest. This is the 22nd lecture in solution series. So, in this video, we will be discussing about abnormal molar masses. When it comes to defining abnormal molar masses, then it is characterized as an anomalous molar mass when the molar masses are greater or lower than the anticipated value when they are computed in chemistry. The colligative qualities are used to arrive at this result. In addition to raising the boiling point, decreasing the relative vapor pressure, and depressing the freezing point of substance, colloidal features include the ease of osmotic pressure. Using the Vant Hoff factor, this method of calculating molar mass is inherently abnormal, as the label abnormal implies. We will find out. Abnormal molar masses, an overview. As a preliminary step, we need to know how many solute molecules remain in a solution or a solvent after the association or dissociation of the solute molecules. The Van 't Hoff factor was developed by Dutch scientist Van 't Hoff in an effort to learn more about the anomalies. We know that ionic compounds, when dissolved in water, dissociate into cations and anions. For example, if we dissolve 1 mole of KCl in water, we expect 1 mole each of K plus and Cl ions to be released in the solution. If this happens, there would be 2 moles of particles in the solution. If we ignore inter-ionic interactions, 1 mole of KCl in 1 kg of water would be expected to increase the boiling point by 2 into 0.52 Kelvin, which is equal to 1.04 Kelvin. Now, if we did not know about the degree of dissociation, we could be led to conclude that the mass of 2 mole particles is 74.5 gram and mass of 1 mole of KCl would be 37.25 gram. This brings into light the rule that when there is dissociation of solute into ions, the experimentally determined molar mass is always lower than the true value. Molecules of ethanoic acid, acetic acid dimerize in benzene due to hydrogen bonding. This normally happens in solvents of low dielectric constant. In this case, the number of particles is reduced due to dimerization. Association of molecules is depicted as follows, like CH3, C double bond O, OH, one molecule, and OH, CH3, double bond O. So O and H will form a hydrogen bond, and O and H form a hydrogen bond. This leads to the dimerization of acetic acid. It can be undoubtedly stated here that if all the molecules of ethanoic acid associate in benzene, then delta Tb or delta Tf for ethanoic acid will be half of the normal value. The molar mass calculated on the basis of this delta Tb or delta Tf will therefore be twice the expected value. Such a molar mass that is either lower or higher than the expected or normal value is called abnormal molar mass. Now let's see what is Vent Hoff factor. In 1880, Van 't Hoff introduced a factor I, known as Van 't Hoff factor, to account for the extent of dissociation or association. This factor I is defined as normal molar mass upon abnormal molar mass, which is also equal to observed colligative property upon calculated colligative property, which is also equal to total number of particles after association or dissociation divided by number of moles of particles before association or dissociation. This is the formula. Here, abnormal molar mass is the experimentally determined molar mass, and calculated colligative properties are obtained by assuming that the non-volatile solute is neither associated nor dissociated. In case of association, value of I is less than unity, while for dissociation, it is greater than unity. For example, the value of I for aqueous KCl solution is close to 2, while the value of ethanoic acid in benzene is nearly 0.5. Inclusion of Van 't Hoff factor modifies the equations for colligative properties as follows. Relative lowering of vapor pressure of solvent is equal to P naught 1 minus P1 upon P1 naught is equal to I multiplied by N2 by N1. Elevation of boiling point is equal to delta Tb is equal to I into Kb into molality. Depression of freezing point delta Tf is equal to I into Kf into molality. Osmotic pressure of solution pi is equal to I into N2 into RT divided by volume. So if you like the video, please please hit the like button, share with your friends, and subscribe to my YouTube channel. And don't miss to hit the notification bell for upcoming videos. Thank you and have a nice day.